Hey guys, welcome back to Harris Helps, and today we're going to be learning how to draw cyclic aldoses. So in this question, we're being asked to draw a cyclic form of alpha D-glucose, and we've been given the straight chain of D-glucose, but how exactly do we convert this into a ring? So every time I hear rings, I always think back, or cyclic rings, I always think back to organic chemistry, where we always draw these carbon rings, something like this. However, since this is biochem and these are monosaccharides, it's going to be flipped to this side. So it's going to look like this instead. You're going to have oxygen right there, and then it's just on its side. So it's still 6 carbons, but you have this oxygen in the top right, and you always will have it in the top right. After that, what you're going to want to do is you're going to want to draw these straight lines at every single point, and this is where these OHs and Hs will go. Once you have that drawn out, you're going to want to come back to the straight chain, and every single carbon you see, you're just going to want to count from top to bottom. So let's do that. 2, 3, 4, 5, 6. And we're going to come back to our ring, and we're going to start numbering again from this will always be 1, this will always be 2, this will always be 3, this will always be 4, and this will always be 5. And we have 5 points, but we have 6 carbons. Just bear with me, it's going to make sense in a bit. So now all we have to do is start placing these OHs and Hs because we already have the carbon set out. So how exactly do we do that? So we're going to skip 1 for now, and we're going to start at 2. So the rule of thumb is anything on the right is going to be sticking down, and anything on the left is going to be sticking up. So as you can see for carbon number 2, OH is on the right, so that means this will be facing down. OH, and then you can see carbon 3, OH is on the left. Carbon 4, OH is on the right. And carbon 5 is on the OH is on the right, but a rule for carbon 5, there's always going to be an H sticking down on carbon 5, and on the top, we're going to put this methanol group, so CH2OH. And in case you guys are wondering where this OH goes for carbon 5, this is this O right here, actually. So now let's clean up these numbers so it looks a little bit better. Now we have that. If you want to add the hydrogens, depending how picky your professor is, you have something like this. And now we're just missing carbon 1. So as you can see in this question, it specifically asks for alpha D-glucose. So for carbon 1, it just depends on carbon 1. So alpha means OH is going to be sticking down, and beta, the OH is going to be sticking up. So since it's asking for alpha, we're going to be putting the OH right here, and there you have it. In case you guys were wondering, a few things. If you ever hear about the anomeric carbon, like where the anomeric carbon is, it's going to be on carbon 1, and it's going to be the opposite side of where the OH is. So since the OH is here, the anomeric carbon is going to be right here. One last tip for you guys, as you can see, this is D-glucose, but if you guys are ever wondering where you have these monosaccharides in a straight chain and you're wondering if this is L or D configuration, you always look at this carbon right here. So if the OH is on the right, this is going to be D configuration, and if the OH is right here on the left, this would be L configuration. I hope that helps you guys. And if you guys have any questions, you can leave them in comments or email it to me directly, as my email is going to be in the description of this video. Hope this helps, and you guys have a good day.